Yeah, so my first attempt to record a full-time video using Audacity kind of failed. It kind of blew up in my face. I tried to explain index notation the best I could. You know what index notation is, right? We have notation for coordinates, x, y, z, I, j, k, whatever have you. It can be anything, cats, dogs, bunnies, whatever you want. But it's usually easier to write indexes down, like x0, x1, and x2, which, yeah, I mean, they are confusing. Like x squared is not x2, they are different things. X squared is x squared and x2 is the second or maybe the third element of coordinates. So if you start from x0, so you have x0 is equal to x, x1 is equal to y, or x2 is equal to z. Usually though, you reserve x0 for your time coordinates, so that's different. Speaking of time, it's actually quite interesting. Times, but we all know that it's a dimension, like the space dimensions, but it's also different. I mean, I can go forwards in space, I can go backwards, I can go left and right, but I can only move forwards in time. I'm actually doing it right now. We're moving 1 seconds per second forwards in time. Yeah, time's a bit of a wibbly wobbly dimension, so it's best to kind of write time down as a different kind of dimensions. Maybe that's why we write it using Greek notations, and we write space coordinates using Latin notations. X mu is time t. But uh, the thing about coordinates is that if they're well behaved, they are linearly independent, which means, like, say me and my friend, uh, we might play together and we might do stuff together, but at the end of the day, we are separate organs. We are independent of each other. We have individual thoughts, we have individual reactions and stuff like that. Coordinates can behave in the same way. They they might interact with each other, but if they're well behaved, they will be linearly independent. They're so only x coordinates will only be there, and y coordinates will only be there. There won't be any mixture of x and y coordinates together. They would be independent of each other. So that's well and lovely, but how do you proceed from that? Well, if I were to find uh, if I were to find the length of two, the distance between 2 points, the length of a line, really, on a piece of graph paper, all I had to do is subtract the coordinates of the final point from that of the initial point. It's the same thing when we try to do it in the context of space-time, but now we just have to add time into the mix. But speaking of time, we have to talk about another important thing, the metric. So, from what I understand, and keep in mind that I'm by no means an expert on it, I'm still learning about the stuff. The metric is kind of the shape of what you want to do. So, for a flat graph paper, the metric is just the identity matrix. For 3 dimensions, it's just 3 by 3 identity matrix. Uh, so, basically what I'm saying is that it doesn't affect the distance. But if we were to crumple that paper up, then each valley and peak would change what you would proceed. I mean, what you would perceive. See, this is what I mean by saying that I suck at recording vlogs or stuff like that. I am not very uh, confident in front of a camera. But anyway, let's stop talking about my insecurities for a moment and finish what I was talking about. Yeah, so the metric is a kind of way of, representing the shape of whatever region you're talking about. And in flat space-time, you usually deal with Minkowski space-time, which is almost an identity matrix, except the first element is -1 instead of a 1. So you have your delta C, sorry, your delta S, which is the action, which is the space-time interval, is equal to is equal to your Minkowski space-time multiplied by the difference of your coordinates xt1 minus xt0, x0 0 minus x01, and so on and so forth. But you can simplify them by saying that, uh, delta S is equal to eta mu nu, because eta is Minkowski spacetime, obviously, multiplied by dx mu dx nu. So the difference between the infinitesimal difference between x mu's and x nu's. Well, from this you can understand that I am by no means an expert on, well, yeah, definitely not an expert on audio recording. I will tell you that much. This thing is harder than it looks. But I'm trying to improve. I'm trying to become more confident, less camera shy, and yeah, that's my current understanding of index notation, which is it's one of the first things you learn when you talk about general relativity, but it's still a complicated topic. Yeah, so if you want to discuss this stuff with me later on, feel free to drop a subscribe, follow. I know that those are extremely iffy stuff. I don't want to make this into those YouTuber call to action stuff, but yeah, the sentiment is the same. I would really appreciate that. And yeah, I will catch you next time then. Have fun, stay safe, and see you later.